Ladies and gentlemen, I want you to look at the car parked in your driveway right now. Or perhaps look at the brochure of the electric vehicle you are planning to buy this weekend. It looks modern, doesn't it? It has a touchscreen, it has LED lights, and the salesman told you it is the pinnacle of engineering. I am here to deliver a very difficult truth. That vehicle is already a fossil. There has been an accident, a massive, catastrophic, industry-defining accident, but you won't see it on the evening news. There is no twisted metal on the motorway. There is no smoke rising from the tarmac, and there are no flashing blue lights. This is a technological crash, and the victims are the millions of electric vehicles currently sitting in showrooms across Europe and the Americas, which have, as of this very morning, been rendered technologically worthless. If you have signed a finance contract on a generic 400-volt electric vehicle from a legacy manufacturer in the last 12 months, you have effectively purchased a Betamax player in a Netflix world. We have spent the last decade in what future historians will refer to as the beta test era of electrification. We accepted mediocrity because we had no other choice. We accepted that lithium-ion batteries are heavy, temperamental chemical sets that can catch fire if punctured. We accepted that charging a car takes 40 minutes because the electrical architectures are archaic and cannot handle high amperage without overheating. We accepted laggy software, plastic interiors, and range anxiety as the price of admission to the green revolution. We called this progress. It wasn't. It was a placeholder. But the beta test is officially over. Chery, through its premium Exeed and Xlantix divisions, has not just iterated on the electric car, they have instigated an extinction event for the current generation. While the world was distracted by trade tariffs and brand wars, Chery's engineers were finalizing a suite of technologies that make the current competition look like relics from the Nokia era. Today, we are going to perform a forensic autopsy on the old world. We are going to dissect the weapons Chery has built to kill the competition: the E0X High-Performance Platform, the Kunpeng Solid-State Battery, and the Gigabit Ethernet nervous system. This is not a review of a car. This is a warning about your investment. Welcome to the silent crash. To understand why giants like Volkswagen, Toyota, and even Tesla are facing such a crisis, we must strip the vehicle down to its absolute core. We need to look at the bones. This is the E0X High-Performance Electric Platform, internally codenamed the E0X Architecture, Manepoi. Most legacy manufacturers are still playing a game of automotive Tetris, Nopal. They are taking chassis designs that were originally conceived for internal combustion engines, ridden with transmission tunnels, compromised crumple zones, and steel floor pans. And they are trying to jam heavy battery packs into them. Or indeed, they are welding together hundreds of stamped steel parts to form a heavy, flexible subframe. This is 20th century thinking applied to 21st century problems. Chery has abandoned this primitive approach entirely. The E0X platform utilizes integrated high-pressure die casting. Instead of welding 70 or 80 individual steel components to create a rear underbody, Chery casts the entire section as a single massive piece of aerospace-grade aluminum alloy using thousands of tons of pressure. Why does this matter to you as a driver? It is not just about manufacturing cost. It is about physics. This process eliminates hundreds of potential failure points, the welds, and increases the torsional rigidity of the chassis to over 40,000 Newton meters per degree. To put that figure into context, that is stiffer than a carbon fiber hypercar from just a decade ago. A stiffer chassis means the suspension geometry remains mathematically perfect even under high G cornering loads. It means the elimination of rattles and squeaks. It means absolute structural integrity in the event of a side impact crash. But the skeleton is also an energy conduit. The E0X is a native 800-volt architecture. I cannot stress enough how critical this number is. Most of the electric vehicle world is still running on 400 volts. The difference is analogous to trying to fill a swimming pool with a garden hose versus a fireman's hose. By operating at double the voltage, you can push the same amount of power with half the current. This reduces heat. By using silicon carbide, IC power electronics, instead of the traditional silicon IGBTs used by competitors, Chery has reduced thermal loss in the inverter by nearly 50%. This unlocks charging speeds that are frankly ridiculous. We are talking about adding 150 kilometers of range in just 5 minutes. You can pull into a station, plug in, walk in to buy a coffee, and by the time you turn around, the car is ready for another 2 hours of motorway driving. If your next car is still stuck on 400 volts, you are buying yesterday's technology at tomorrow's prices. Now we arrive at the most critical component, the heart of the machine, the battery. For 15 years, the entire automotive industry has been held hostage by liquid lithium-ion chemistry. We all know the risks involved. We know about dendrite formation inside the cells. We know about thermal runaway. We know the terrifying reality that if a standard EV cell is punctured in a high-speed crash, it becomes a self-oxidizing fire that cannot be extinguished by water because it generates its own oxygen. Legacy brands told us that solid-state batteries, the supposed holy grail of energy storage, were 10 years away. They said it was science fiction. They said it couldn't be mass-produced. Chery didn't listen. Chery has officially unveiled the Kunpeng Solid-State Battery series. This is the single technology that renders the internal combustion engine truly obsolete. By replacing the flammable liquid electrolyte with a solid ceramic or polymer separator, they have achieved the impossible triad: density, safety, and speed. Let's look at the numbers, because they are staggering. The energy density of these new cells hits 600 watt-hours per kilogram. Let me contextualize that for you. The best batteries from Tesla, the 4680 cells, or BYD, the Blade battery, hover between 150 and 290 watt-hours per kilogram. Chery has effectively tripled the energy capacity in the same physical space. This translates to a real-world range of 1,500 kilometers on a single charge. You could drive from London to Rome without stopping to recharge. You could cross entire states without once looking at the battery gauge. But the real revolution is safety. Chery has subjected these batteries to torture tests that would turn a standard EV into a crater. They have cut the cells in half with saws. They have shot them with bullets. They have driven steel nails through them. The result? Zero fire, zero smoke, zero explosion. The chemical volatility is gone. This single technological leap renders the fire safety arguments against EVs null and void. We are looking at a future where range anxiety and fire anxiety are concepts we will have to explain to our grandchildren as historical curiosities. A strong body and a powerful heart are useless if the brain is lobotomized. And this is where the gap between Chery and the Babos old world becomes a canyon. Walk into a dealership today and look at a Volkswagen ID.4 or a Toyota BZ4X. Under the skin, those cars are communicating using a system called CAN bus, Controller Area Network. It was a standard developed by Bosch in the 1980s. It is a series of copper wires shouting analog signals at each other. It is slow, it is heavy, and it is easily overwhelmed by modern data loads. That is why your infotainment screen lags. That is why the voice assistant is stupid. That is why over-the-air updates often fail. The Chery E0X platform discards this relic. It utilizes the EEA 5.0 architecture. This is based on Gigabit Ethernet. We are talking about data transfer speeds that are 100 to 1,000 times faster than the industry standard. This is the difference between a dial-up modem and fiber optic broadband. Why do you need this speed? It's not just for watching Netflix or playing games. It is for survival. It allows for a service-oriented architecture, SOA. It separates the hardware from the software, allowing the car to update and evolve like a smartphone. But crucially, it feeds the dual NVIDIA Orin X chips, which deliver 508 TOPS. tera operations per second to process data from high-definition LiDAR, cameras, and ultrasonic radars in real time, to identify a child running into the road and react before your foot even touches the pedal. You need massive bandwidth. While legacy brands are struggling to get their maps to load without freezing, Chery has built a data center on wheels that thinks faster than a human being. The car is no longer a machine. It is a digital organism. Finally, let's talk about how this technology translates to the tarmac. How does it feel to drive a supercomputer? Chery calls their solution the Flying Fish Chassis 2.0. It is a poetic name for a brutal display of engineering dominance. Because of that Gigabit Brain we just discussed, the suspension is no longer reactive. It is predictive. The E0X uses its LiDAR and cameras to scan the road surface ahead, creating a 3D topological map of every pothole, speed bump, and camber change millimeters before the tires make contact. The system then adjusts the CDC, continuous damping control, electromagnetic valves, and the dual-chamber air suspension instantly. Note that I said dual-chamber. Most competitors use single-chamber air springs, which are floaty and imprecise. Dual-chamber allows the car to instantly stiffen the spring rate for dynamic cornering or soften it for motorway cruising. The result is a sensation of decoupling from the road. The wheels move violently up and down to absorb the terrain, but the cabin remains perfectly flat. It is the magic carpet ride that Mercedes-Benz spent decades trying to perfect, executed here with digital precision. And let's talk about agility. The Xlantix ES features active rear wheel steering. At low speeds, the rear wheels turn in the opposite direction to the front, effectively shrinking the wheelbase. This allows a 5-meter-long luxury saloon to have the turning circle of a compact hatchback. It can navigate tight European streets and parking garages with an agility that defies its physical dimensions. At high speeds, the wheels turn in the same direction, allowing the car to crab lane changes with absolute stability. The chassis is an active participant in the driving experience, constantly fighting the laws of inertia to keep you safe and comfortable. It makes a traditional mechanical suspension feel like a horse and cart. Part 6. So, where does this leave us? Where does this leave the consumer standing in a dealership today? It leaves us with a stark realization. The automotive hierarchy we grew up with is gone. The badge on the bonnet, whether it's a German star or a Japanese ellipse, no longer guarantees technological superiority. In fact, right now, it guarantees the opposite. It guarantees you are paying a premium for legacy engineering. Chery has not just caught up, they have leapfrogged the entire industry by a technological generation. The combination of the E0X Die-Cast body, the Kunpeng Solid-State energy density, and the Gigabit Ethernet Brain creates a package that makes current EVs look like relics. The silent crash has happened. The wreckage of old technology is piling up in the showrooms of legacy manufacturers, disguised as new models, moilis. But now you know the truth. You know what is underneath the skin. The future isn't coming. It's already here. And it's built on an E0X platform. This is Drive and RPM. If you want to survive the future, make sure you are subscribed. See you in the next one.